watch the screen again and you find a pertinent question and it reads, what would solving an equation such as 3x to the power 2 minus 3 all over 2 is equal to 36 involve? That is, what and what are involved in solving this? It means that this is a case in point now. When trying to solve this question, that is, when trying to solve this equation, what and what are involved? You see, before we start, let us compare the left-hand side alone. That is where the unknown is found. Because to solve this equation means that we have to make this x, which is the target, the only unknown in the entire equation, possess power of 1, coefficient of 1, divisor of 1, adder of 0, and it is also supposed to be positive at the end of the whole process. Now watch this equation again. What obstacles are preventing this left-hand side from possessing those characteristics of correct expression of final solution to an equation? It is removing those obstacles that it means to solve this equation. We agree that having seen this left-hand side, there are obstacles that must be cleared. It is clearing those obstacles that we call solving this equation. To solve this equation, let us note those obstacles one after the other. To do so, we are comparing the left-hand side with this expression. What it means is that the whole left-hand side here could be compared to what we have this place. Watch out for some observations in this expression, which we tend to use to compare with the case in point. We take it that this x here is the same thing as this x at this point. But look at the power of this x, it is 1. What is it here? It is 2. Look at the coefficient of this x here, it is 1. What is it here? It is 3. Look at the divisor of this expression, it is 1 here. What is it here? It is 2. And look at the adder, it is 0. But what you find here, it is minus 3. What it means is that in making this become like this, we have responsibilities, we have obligations at hand here. This is why we make conclusions that in solving this equation, we have to bear it in mind that there are obstacles to be cleared. What are they? The coefficient of x in this expression is 3 instead of 1. See 3 here and see what it is supposed to be. Next, the power of x is equal to 2. See the power of 2 here. See what it should be. It should be power of 1. Next, the divisor is 2 instead of 1. Yes, see this divisor, it is 2. Meanwhile, it should be this 1. Next is that the adder is equal to minus 3. See the adder here, minus 3. Meanwhile, it should be 0. Therefore, solving this equation means making this power become 1. Making this coefficient become 1. Making this 2, which is divisor, become 1. And making this adder, which is minus 3, become 0. Of course, that is something we have already. What is it? It is already plus. That means we don't have a case with the sign here. The sign it has is the same sign it has here. So we have only how many obstacles? 1, 2, 3, 4 obstacles. The number of obstacles in an equation determines how long it takes to solve that equation, and perhaps how much energy will be required to solve it. Now, solving this equation simply means that we have to clear all these obstacles. When they are cleared, we now say that this equation has been solved. In the next objective, we learn the pertinent skills that we ought to have as tools for solving equations. When we have known all the obstacles preventing your known from having the correct notation, what are we expected to do? We are expected to clear each of those obstacles. To clear each of those obstacles, we apply a skill. What are the skills of clearing the obstacles preventing your known from having the correct notation? That takes us to the third objective. Please watch the screen to find the skills of clearing these obstacles. Now you see the skills of solving ordinary equations, ordinary algebraic equations written on the board. These skills are the same thing as the skills of overcoming those obstacles we identified earlier. There are about 12 skills needed. Number 1, making other become 0. Number 2, making coefficient become 1. Number 3, making power become 1. Number 4, making divisor become 1. Number 5, changing numerical sign or making the variable become positive. Number 6, opening brackets. Number 7, collecting like terms. Number 8, factorization. Together, skill number 7 and skill number 8 could be called unifying the variable. In the course of time, you will see why the two together are called this. The number 9, expanding brackets. Number 10, clearing roots. Number 11, reciprocalization. And number 12, trigonometric inversion. Please take note of those ones that have asterisks before them. This is number 8, that is factorization. Number 9, expanding brackets. Number 11, reciprocalization. And number 12, trigonometric inversion. They are 4 in number. These 4 will not be treated in this topic. When the time is ripe, we pay attention in a separate arrangement to these 4. So out of the 12, we are paying attention to 8 different skills of solving ordinary algebraic equation. In applying each of these skills, there is one common practice, one common action we have to take. This action, if we fail to take it, the entire process of solving an ordinary algebraic equation will be defective. What is this? What is this action that is common to all skills? That takes us to the 4th objective of this lesson. Please watch the screen to find the next objective, and that is the fundamental law of solving ordinary algebraic equations. Let's see. The fundamental law of solving an equation, as you can see on the board, states any new operation carried out to change the value of one side of an equation must also be carried out on the opposite side to maintain equality. What does this mean? It means that because we know that every equation contains the left-hand side and the right-hand side, that is, every simple equation contains the left-hand side and the right-hand side. After carrying out many operations with equations, this conclusion was reached you can do the same thing and the same conclusion I'm sure you're going to reach. What is it? If we carry out any operation such as addition, subtraction, multiplication, division, or any other operation at all that changes the value of the left-hand side, if we refuse to carry out the same operation on right-hand side, what we would have created is not an equation. Watch a proof here on the board. This is going to help you understand what I mean by that. What I have on the board is 3 plus 5 is equal to 8. Of course, this is an equation. Why do we refer to 3 plus 5 is equal to 8 as an equation? It is because I defined equation before as any statement that consists of a mathematical operation and a result. 3 plus 5 is a mathematical operation, and it gives us the result right away with this equality sign. So this entire statement here in a mathematical form is an equation. But this is not an algebraic equation because there is no variable anywhere in this expression. So, but just know it that this is an equation. We could call it a constant equation. Now, let us try to prove that anything that we do to the left-hand side must be repeated on the right-hand side. That is, if that which we do changes the value of left-hand side. If we do something to the left-hand side and it does not change the value of the left-hand side, we must not necessarily repeat the same procedure on the right-hand side. Now watch out. I want to add 2 to this left-hand side. Only 3 and 5 make the left-hand side. Let me add 2 to them to make 3 plus 5 plus 2. And let me not do anything to right-hand side. We see that it is equal to 8. The comment on the other side of it corresponding to this expression shows that this is no longer an equation. Why is that no longer an equation? If you add 3 to 5 and to 2, the result is not equal to 8. In every equation, the value of left-hand side must be equal to the value of the right-hand side. That is why we call it equation. That is to say, the process or a condition of being equal is what we refer to as equality. And then the statement of equality is what we refer to as equation. So the entire statement is equation, and that sign that separates both sides is sign of equality. Now let's make progress. What if we now want to make it become an equation? Since we now agree that line 2, this line 2, is not an equation, let's try and do the same thing we did in left-hand side on the right-hand side. Don't forget that I added 2 to left-hand side to bring it to 3 plus 5 plus 2. 2 is now the new thing I have done to this left-hand side. I have added to the left-hand side. Does it change the value of this left-hand side? Surely, yes. If you add 3 to 5, it is 8. If we now add 2, the left-hand side should be equal to 10, no longer the former 8. What it means is that adding 2 to this left-hand side has changed its value from 8 to 10. That means that the right-hand side also must be equal to 10. How do we make right-hand side become 10? I must repeat the same value changing operation on this right-hand side. And what is it? I must add the same 2 to the right-hand side, giving us 8 plus 2, which is also equal to 10. Therefore, on the left-hand side, we have 10 as the result. On the right-hand side, we also have 10 as the result. We now see correspondingly that this expression has again become an equation. Now, if we repeat many other operations, such as subtraction, multiplication, division, and other operations on the left-hand side. And after we carry out those operations, the left-hand side value changes. Certainly, as compared by this law, through observation, we are to repeat that same procedure or that same operation on the right-hand side. That is the message carried by this fundamental law of solving equations. Again, we say any new operation carried out to change the value of one side of an equation must also be carried out on the other side, that is, on the opposite side, to do what? In order to maintain equality, that is, to make sure that both sides are equal, to ensure that the value of left-hand side is equal to the value of right-hand side. But you may want to know, is there any operation in mathematics which, when carried out, does not change the value of either left-hand side or right-hand side? Yes, we can identify about 3 different kinds of mathematical operations which, when carried out on left-hand side of an equation, will not change the value of that left-hand side. What are they? 1, if we clear brackets. Clearing brackets does not change the value of any side of an equation, which means it is not compulsory that if we clear brackets in left-hand side, that we must clear it also on the right-hand side, except by circumstance, it becomes also necessary to clear another bracket on the right-hand side. If we clear bracket both sides, the reason is that there is a coincidence that we have 2 brackets on both sides. It is not because we cleared on left-hand side that you will clear on the right-hand side. It is just because we have brackets on both sides. But if we have bracket just one side of an equation, then if you clear the bracket, don't struggle to carry out the same thing on the right-hand side if there is no need for that. Another operation that does not need to be carried out on both sides is factorization. If you factorize one side of an equation, do not insist on doing the same thing to the other side, except by coincidence, both sides need it. The third one is collecting like terms. If you collect like terms on one side of an equation, do not insist on doing the same thing to the right-hand side, except there is a need for that. So this is all that we have to bear in mind as we prepare to use the skills that we have just been told to apply and get some equations solved. Please do not forget this fundamental law of solving equations. Not just ordinary equation, but all other things called algebraic equations, not just ordinary ones.